Exercise 10.1, question number 3. Find the distance between P x1 y1 and Q x2 y2 when PQ is parallel to y-axis. Second, P2 PQ is parallel to x-axis. I'll start by writing the distance between 2 points. I know that whenever the two coordinates are given, the distance PQ can be written using the distance formula, which is x2 minus x1 whole square plus y2 minus y1 whole square. Now, in the first case, whenever PQ is parallel to y-axis, so the first case is PQ parallel to y-axis. Let me consider a line which is parallel to y-axis. You can consider any line. So let me consider a line like this. Okay, let me name this as P, which is x1 y1. Let me name this as Q, which is x2 and y. Now, what will be the coordinates of these point? If I write the coordinates of these point, the point P can be written as 3 comma 6 and point Q can be written as 3 comma 1. What do I observe here? Do I observe that the value of x1 and the value of x2 is the same? You can try this with any line which is parallel to y-axis. Every time the value of x1 and x2 will remain the same. So I can tell that the distance PQ is going to be equal to just the root of x2 minus y1 y2 minus y1 whole square, because if x1 and x2 are equal, x2 minus x1 is going to be 0, so PQ will be given by root of y2 minus y1 whole square. So this can be written as PQ, which is the modulus of y2 minus y1. So this is the distance PQ when PQ is parallel to y-axis. Similarly, the distance PQ, again it is given by the distance formula, which is root of x2 minus x1 plus y2 minus y1 whole square and whole square. Now, the second sub question, when PQ is parallel to x-axis. Now I can consider any line which is parallel to x-axis. So let me consider this line. Say this is your point P, which is x1 and y1. Say this is your point Q, which is x2 and y2. Let me write the coordinates of the same. If I have to write the coordinates of the point P, I can write it as say 2 comma 3, and Q it is going to be 6 comma 3. I can observe that the value of y1 and y2 are the same. If y1 and y2 are the same, then y2 minus y1 is going to be equal to 0. So the distance PQ when it is parallel to x-axis is given by root of x2 minus x1 whole square. Now I can write PQ as x2 minus x1 in the modulus. So this is the distance PQ when it is parallel to x-axis, and this is the distance PQ when it is parallel to y-axis. Let us move to the next question. Fourth one, find a point on the x-axis which is equidistant from the point 7, 6 and 3, 4. So let us point out, let us take this point to be A, this point to be. Now let us plot the same on the graph. Point A is 7, 6. So 7, 6 somewhere over here. So this I can take as your point A. Point B is 3, 4. So point B is 3, 4. We have to find a point on the x-axis here such that it is equidistant from both the point. What does it mean? It means that I can choose any point on the x-axis. Say this is C. Now the distance BC and AC should be equal. That is what equidistant means. What will be the coordinates of C? That is the question. Now I will start the question by writing any point on the x-axis can be written as x comma 0, right? Any point on the x-axis is x comma 0. So I can consider C as x comma 0. They have given this point C is equidistant from B, A and B. The points A and B which are 7 and 6. So I can tell that what is given in the question. It is given that the distance AC should be equal to the distance AB. This is what is given in the question. So I can find out the distance AC. So distance AC is going to be the root of x2 minus x1 whole square plus y2 minus y1 whole square. Now let me consider A, which is 7 comma 6, and let me consider C, which is x comma 0. Let this be x1 and y1. Let this be x2 and y2. If I substitute the same, I will be getting AC is going to be root of x2 minus x1. So x minus 7 whole square plus y2 minus y1, 0 minus 6, 0 minus 6 whole square. So I will be getting AC is under the root x minus 7 whole square plus 36. So let me consider this as equation number 1. Similarly, I can find out the distance BC also. So the distance BC, if I consider B as 3 comma 4, which is x1 y1, C to be x comma 0, which is x2 and y2, the distance BC is given by the distance formula. So the distance BC will be given by x2 minus x1 whole square plus y2 minus y1 whole square. Upon solving, BC is going to be equal to under the root x2 minus x1. So x minus 3 whole square plus y2 minus y1. So y2 is 0 and y1 is 4. 0 minus 4 whole square. So I will be getting BC is under the root of x minus 3 whole square plus 60. You can consider this to be equation number. Now, in the question, they have already given that AC is equal to AB. So I can tell that AC and AB, if they are equal, equating equation number 1 and 2, equating equation number 1 and equation number 2, I will be getting x minus 7 whole square plus 36 under the root should be equal to root of x minus 3 whole square plus 16. Now, squaring on both the sides, I can cancel out the square roots. Upon solving the brackets, I will be getting x minus 7 whole square plus 36 on the LHS. So x minus 7 whole square plus 36, this is what I'll be left on the LHS, and on the RHS it will be x minus 3 whole square plus 16. So upon expanding, x square minus 14x plus 49 plus 36 is going to be equal to x square minus 6x plus 9 plus 16. I can cancel out x square from both the sides. I can write over here minus 14x plus 49 plus 36. It can be written as 85. This is going to be equal to minus 6 plus 9 plus 16 is 25. So upon solving, I can send minus 6 to the other side and 85 to RHS. If I do that, I will be getting minus 14x plus 6x is going to be equal to 25 minus 85. Minus 14 plus 6, it is minus 8x is going to be equal to minus 60. So I can write 8x is going to be 60. If 8x is going to be 60, I can write x as 60 divided by 8. Upon simplifying, I will be getting the answer as this is 4, this is 30, half of this is 15, half of this is 2. So x is going to be 15 over 2. So the final answer is the point on the x-axis. This is what we have to find out. So the point on the x-axis which we have taken as C is x comma 0, and we have got x as 15 by 2 comma 0. So this is going to be the coordinate C. This is the point which is equidistant from both A and B. Let us move on to the final question for the session. Find the slope of a line which passes through the origin and midpoint of the line segment joining P and B, 0 comma minus 4 and 8 comma 0. Let me first plot the lines, the points P and Q. So P is 0 comma minus 4, so P is over here, and Q is 8 comma 0. Q is 8 comma 0, it is over here. So this is your Q, and this is 0 comma minus 4. Let me join the same. All right, now we have to find the slope of a line which passes through the origin. So the origin is over here, which is 0 comma 0. I can represent it with O. We have to find the slope of a line which passes through the origin and the midpoint of the line segment PB. So let me consider M to be the midpoint of PB. So I can, or I should find out the slope of the line OM. This is what is being asked in the question. So they have taken PB, right? So let me take PB. It's not PQ. Now, I will start the question by finding out the point, or rather the coordinate of M. If I have the coordinate of M, I can easily find out the slope of the line, right? Now, to find out the coordinate of M, I need the midpoint formula, right? So from the midpoint formula, I can tell that M, which is x comma y, it is given by x1 plus x2 divided by 2, y1 plus y2 divided by, where P, which is 0 comma minus 4, this can be taken as x1 y1, and the other point B can be taken as 8 comma 0, which is x2 comma y2. Upon solving, I'll be getting the value for M over here, rather the coordinate of M. So M x comma y can be written as x1 plus x2, which is 8 plus 0 over 2 comma 0 minus 4 over 2. So I will be getting the value of m, or the coordinates of m, as 4 comma minus 2. So the value of m is 4 comma minus 2. Okay, 4 comma minus 2. So somewhere over here, actually it should be over here. Okay, I have done a freehand drawing, so it is little deviating, but I hope you get it right. So the point m we have got, which is 4 comma minus 2. Now we have the point o and m, and we have to find the slope of the line om. That is what we have to do, right? So I'll be writing, to find slope of om. This is your o, which is 0 comma 0, and m, which is 4 comma minus 2, right? I need not write what is p and b here, so I can just take this as 4 comma minus 2. Now let me consider m, which is 4 comma minus 2, to be x1 and y1. x1, y1. Let me consider point O, which is 0 comma 0, which is the origin, to be x2 and y2. Now I know that the slope of a line m is given by y2 minus y1 over x2 minus x1. So the slope of the line will be given by y2 minus y1, 0 minus of minus 2, whole divided by x2 minus x1, 0 minus 4. So m I will be getting as minus into minus is plus, 2 over minus 4, upon cancelling I will be getting m is equal to minus 1 by 2. So the slope of the line which passes through the origin and the midpoint of the line segment joining PB is m, which is given by minus 1 by 2. So this was the point P, this was the point, and m was the midpoint of PB. We have found out the slope of the line which passes through the origin and the midpoint of the line PB, and the value we have got as minus 1 over 2.